Okay, perfect. Okay, good morning or good afternoon, guys. Today I'm gonna present about the LLM-powered network intrusion detection. And just to a quick introduce on myself, so I'm a currently machine learning engineer at Pattern, and I'm also a current like MS/CS student at Georgia Tech, and also just grad from BYU, and I was able to won 7 different hackathon competitions in my life. So let's go to the next one. So the first thing is like the evolving of the threat landscape. So cybersecurity attacks are becoming like increasingly sophisticated and frequent, and some of the like currently like LLM and also machine learning fields, and in this like era, the problem is they're using those tools to diverge into our system. So as you can see from the chart, um, these are like some surveys for like the currently like the cybersecurity experts, and then what are their like projectile. So like 66% of the people are predicting that like AI and machine learning technologies will trigger a lot of different like cybersecurity attacks. And so traditional security systems are struggling to keep up with the novel and evolving threats, and the interconnectedness of modern systems such as Internet of Things or cloud expands the attack surface. And also we need a new approach to proactively defend our networks. So limitations of yesterday's defenders, such as signature-based NIDS, which is network intrusion detection system, and also anomaly-based network intrusion detection system as follows. So for the signature-based NIDS, it like relies on databases of known attack patterns, and it cannot detect really new attacks. And also attackers can easily modify techniques to evade detection. And also constant signature updates are required as well. And anomaly-based NIDS is identifies deviation from normal network behavior, often suffers from a high rate of false positives, and also requires a learning period to establish a baseline. And sophisticated attackers can slowly introduce malicious traffic to blend in. So if you can see the graphs on the behavior, this is like the anomaly detections. So when there's the drifted anomaly or undrifted anomaly or normal drifted anomaly, we used to detect those patterns when we use the machine learning, like the trainings over there, and detect it. But these are like the kind of drawbacks from it. So a new era of intelligent threat detection is like large language models or advanced AI models trained on vast amounts of text data, and they excel at understanding context and identifying complex patterns in data. And LLMs can analyze system and network logs like natural language, and this offers the potential for more adaptive and context-aware threat detection. So some of the ones that we have look into is turning logs into language for smarter analysis. So when we look at our log, so we are like definitely like looking for the security logs. So the inputs data are normally looking at that, like January 17 or something like that, and Damascus, something like that. Those are the logs that save into our cloud or into our databases. And then somehow like the human language, we cannot really detect it very easily. So we kind of process it by using the tokenizer and transform into tokens. And we are thinking of using BSidesSLC, and then we put the outputs and then probability scores on it. So treat systems and network logs as natural language and use natural language processing techniques to parse and categorize log entries, and also extract key information like IP addresses or error codes, and identify pattern in the case of security incidents, and also perform semantic analysis to understand the context. So fueling our intelligence, so we pre-train our data based on the AIT log data set version 2.0. And there are like numerous data, so a lot of realistic synthetic logs. The data sets simulate like cybersecurity attacks on smaller enterprise, and also network using realistic host logs, including web servers, VPNs, and firewalls. And there are a lot more categories of the attacks, but we kind of categorize them into kind of smaller multiple categories. And structure for evaluation, so logs are organized per host with level attack events useful for testing intrusion detection systems, federated learning, and alert aggregation. And there are a lot of different scenarios, and as you can see, there's like 2 million and 1 million data, a lot of million data over here that we pre-train on. So the reason why we use this BERT is like the brain of our system. Of course, like BERT performs it better, but for the cybersecurity to work really fast, because we have to be like in like not just a second, but it can be smaller inference time than that, because like BERT takes a lot longer time for the inference time in seconds. So we use the DC BERT to pre-train on it, and it is a smaller and faster version of BERT and optimized for CPU inference. And also, it also excels at interesting understanding the context of the log data as well. So just briefly explain about the DC BERT. It's like we have a teacher model such as like BERT model, which use a lot of different contexts. As you can see, parameters over here is almost double. 110 million parameters we are using for training the BERT, but we are using the knowledge transfer to distill it. That's the reason why it is called distill BERT. And we distill the knowledge in a way that for our student model, which is like the distill BERT, can train it a lot faster and with a lot smaller data, but also performs a lot greater, like almost like it's only 1% or 2% difference between the BERT base and distill BERT, as you can see on the databases, and it performs a lot better than LMO. And so this is like the kind of demonstrating the effectiveness of model performance. We achieve like strong results through like 5-fold close validation. As you can see, this is like this is the one patterns that we want to keep looking at, and as you can see, they're like the little bit off in a very few instances. Also, there's a big possibility that it could be overtrained, but we're training the really smaller amount of data compared to the like industry level, though it still performs a lot better performance over here. And also, we have a 3D graphics design that I'd like to demonstrate. So just to give you more context, when we change the log data into the multiple, like the vector logs, it is a lot multiple dimensions, but we kind of like grab the graphic design into the 3D to visualize yourself better in the human's perspective. So let's do that. So just to give you just for a second, and then so this is like the 3D graphic design that is the X, Y, Z level, and these like the attacker scenarios over here, and then you can see that there is every kind of like similar logs data are transformed into these log spaces, and this is very easily visible into the LLM space, and then you can easily like debug it as well. Yeah, so this is like how we kind of save into the database and then track it and then parse it. Okay, let's go back to here. Okay, and so model deployments, we have to open source it. So we have our model already into the Hugging Face. It is called Insight, and we train our model and host it on Hugging Face that we can easily track it. And if you want to use like the Python or the Jupyter Notebook to test this model, you can easily like use the transformer and then retrieve from the pre-existing models, and you just need to copy and paste the current URLs over there and then retrieve the model. And you can use it as an API as well. And this allows for easy downloads and tracking of model versions. So how to build it into our real system? So this is like for the very basic system that we use for like free, but it can be a lot scalable if you use different models. So as you can see from the database, there's the vendor log and also we made our Python packages over there that you can install it by using pip install over there. So there's a file watcher, and then it goes to all the logs into Redis queues that we can simultaneously run it, that we can put into our worker. Of course, like the thread classification is BERT, and then it can be either goes to the Redis queue again when we find a new patterns that we can train more on it into recursively, and also incident response recommendations. We are using Gemma, but you can use a lot of different models, because a lot new greater models came out to analyze it. But that time we used the Gemma over there, and then the DB as a SQLite, and then we display to the front end SQLite. And so this is kind of visualization works in what kind of attacks and the recent attacks are in. This is just an idea about how you can use it as a kind of for the UI perspective. If you want to implement this system, like similar system into your company, that you can and what kind of geographically based attacks occurred or unusual attacks, and look data. And this is like the log that you can also track it. Of course, this is the pretty easy one. So advantages of the LLM approach is like adaptive and context-aware threat detection. So LLMs can learn and adapt to new evolving attack patterns without constant manual updates. So some of the things that you can think of is like you can just, like when there are numerous accounts over there, and then you just assign like what is the limits for the kind of abnormal behaviors with this account, and then you can just detect it by LLM prompting it, and also reduce false positives, and we can filter out irrelevant warnings by understanding the broader and operational context. And this is like very important because like in the cybersecurity area, like I don't know very much, but like the false positives is very costly as well, which is very shown to the very traditional ML models. And detection of novel zero-day attacks can detect deviation from normal behavior without relying on predefined signatures. They can recognize like subtle anomalies in real time. So this is like something that I mentioned. So traditional ML and deep learning approach works well with structured data, requires feature engineering for unstructured data, and can vary, and some models are more interpretable than deep learning, and anomaly-based methods can detect novel threats but may have higher false positives. It can be less computationally intensive for some models. And large language models can process unstructured data like logs more naturally and offers the potential for natural language explanations of detections. And also, it also shows promise in detecting novel threats to the contextual understanding and requires significant computational resources for training and inference. But if you pre-train it and also train it in a loop, since distribute is kind of like cost less, that it also compute really fast as well compared to normal models. So future improvements with LLM inference models that we are thinking right now is enhanced threat detection. So introduce a new classification category sometimes when it recognizes that, hey, this is based on the similarity scores, it is very deviant from the other existing ones, then we can maybe use the LLM to create a new classification category to identify emerging types of attacks. And then we train this deep model again. And then also user behavior anomaly detection, implement advanced pattern recognition to detect abnormal account login behaviors and potential security breaches in a loop. And also scalable production environments. There are a lot of different like structured like SQL models, like such as PostgreSQL, or you can use Snowflake if you like. And there are a lot of models that you can use to store those data. And also, right now we are using Redis, but you can use a different like kind of tools to use it, like AWS tools, or like for the orchestrate and everything. So just based on what your company can afford you to. So just summarizing, like embracing the power of LLMs for a more secure future, that you can just you don't have to like change dramatically your existing system, but just adding the LLM layer over there to analyze it better. And if there is a kind of abnormal behaviors, so for instance, like there is a case when we have like the accounts, like the login, it's like multiple like networks attacks at a time, and then somehow it is not very recognizable in the traditional ML model, but we kind of track into the backend loop about what would the user behavior if they successfully log into our system, and then because like they don't know about our system, they first try to figure out where they are and everything, and then they dip into just ask about, hey, what is this system about, and then goes more in it, and we detected that behavior about that, and then we were able to just suspend it, that we were not able to cost more like from that account breaches. But LLM, since it is kind of like the text-based, so you can really recognize it as well. And thank you. This is like my presentation today. But so far, like if you have any questions of the existing system, please ask now, that I can go over and then answer you any questions you have.